We'll now have a last presentation on how, again, on sea level. We started this session on sea level and we will end it on sea level, and how we adapt to rising sea level by Svetlana Jevrejeva. Jevrejeva.
Thank you. Thanks a lot for being here. As you could see from my title, I will give you some example of how we survive with rising seas. In general, I'm a physical oceanographer, sea level scientist from National Oceanography Center. But my examples, and I will show some, it's more related to impacts, to economic impact, to social implications of sea level rise. I will give briefly, I don't think I need that to do now because you will know everything already. Then I will show future sea level projections, and I will show estimate of economic impact of sea level changes along the global coastline. And I will show some impact for extreme sea levels, mainly due to sea level rise. And I have a short summary. And of course, I will link it to monitoring and to use of satellite altimetry data. Just to summarize what you already heard today many times, but I will add a little bit different figure, as you could see on the right. This is a summary about sea level changes for the last 300 years. This is from observations, mainly tide gauges. You could see huge error bars because we have only few long-term tide gauges. And the red color on the plot, blue color, light blue. This is a small portion of satellite altimetry, but it's a huge contribution to our understanding about sea level rise. And this is a global curve. And red and blue color show projections. So you could see that for the last maybe 300 years, sea level was very stable. That's why we have huge development in the coastal areas. Civilization is developed along the coast. But then in the 20th century, you could see some rise. But then unprecedented challenges, how we deal with future sea level rise. And here is the components. And today you saw all these presentations that we could individually measure those components, combine them, and have proper understanding about the budget. I would like to give a credit to satellite altimetry missions, because until 1992 we had very naive understanding of sea level rise, that it most probably rise not exactly uniform, but very close. But the picture here, this is from Annie's paper, recent picture. You could see different color, and you already know that in general, during this time period, sea level rise is about 3.5 millimeter per year. But you could see huge areas with dark red color, which is above global mean sea level rise. And we also use satellite altimetry to estimate acceleration. You saw figures that global sea level rise is accelerating, but what you see on the bottom two figures, so the red or brown color shows along the coast. It's not exactly on the coast, it's 20 kilometers from the coast, but it already shows that red color, it is where the acceleration for 30 years of satellite altimetry is above global number. And the blue, it's still acceleration, but it shows where the number for acceleration is below the global number. So there are many, if I choose different time period, the same with trends, it will give different pictures. So it shows very dynamical changes in sea surface height changes. So how about future? I will show only here future for by 2100, and you could see that depending on scenario, it could be up to 2 meters, but let's say 1 meter, 2 meter. So 20th century was only 20 centimeters, and it's already had huge impact. If you look on the plots, this is just to give some idea what is the cost of sea level rise due to flood damage along the coastline. I give example for like one where the bars, this is percentage of GDP for the global scale. And red color is only half meter of sea level rise, assuming we have 1.5 degree warming. And then we have this magenta color, which corresponds to 1.8 global sea level rise, and in the different locations it will be close to that, but not exactly. But what you see, example for Vietnam, that even if we follow 1.5 degree, in the future, follow red color, you will see that Vietnam will pay 5% of GDP just to cover flood damage. So now it's 0.05%, but it is huge, huge changes. And if we will have businesses usually warming, so it will end up with huge number, as you can see at the end, about 26% of their GDP. It's a little bit misleading to use only economic impact, because if we look on Bangladesh, and of course they have almost no infrastructure on the coast, that's why percent of GDP is relatively low. But if you look in another data on the right, so 4 millions, it's 2.5% of population were displaced already in 2019 due to losing agricultural land and salinization of the soil. And then it projected that by 2050, around 13 million people will be displaced. And by 2080, the country could lose 18% of coastline. So this I just give you idea about importance to understand sea level rise in different locations, not just in Europe, but in many other locations where we hardly have any measurements exactly on the coast. It leads a link to how do we make decision about adaptation, what do we consider, and how many data we need, and what kind of time scale we need to build coastal defense. I use quite often this figure, this slide. This is, if you look, this is abandoned wall to protect City of London. So it initially was built in 1879 after storm, and then it was extended again and again. And in 1953, after this big storm in Europe, the decision was made to build another completely different defense system, like this Thames barrier. But it took almost 30 years to design and build. So I show this to say we need knowledge, we need measurements, and we need understanding how extreme and sea level change in future to be able to protect coastline. If you ask me why I show result for modeling for future, this is mainly to show hotspots where we expect huge changes in extremes. On the right, this is magnitude of extreme sea level. This is combination of wave, storm surge, tide, and sea level. Of course, for present day, we say it's almost negligible, but you could see that most of the map is kind of green, blue, up to 2 meters, and some, of course, like European location, China, and some other places have magnitude up to 6 meters. This is events 1 in 100 years. But if you look at the same events once in 100 years, magnitude of extreme, you could see that most of the colors getting red and brown. And this shows an increase in magnitude leading to inundation. And we could identify from this map areas, let's say Africa and South America and Southeast Asia, India, with huge increase. But I will later show the map. We hardly have any observations there. And I will link to ESA project, but it is not exactly on a coast yet. And that slide was about magnitude, changes in magnitude of extreme sea level. But this one shows time. So brown color and red color will represent decade and other colors as well, of course. But when event in 100 years will have probability once in a year. And you could see that equatorial and tropical areas, Mediterranean and small islands, already next decade, they will have events 1 in 100 years, once in a year. Of course, it's projected. Of course, it is just model simulations for all these waves, storm surge, tide, and sea level rise. But it indication area where we need to have monitoring of sea level rise, because most of these changes link, 90% of changes link to sea level rise, only 10% to changes in atmospheric circulation. And this is almost my final slice. It's a little bit similar to what Ani presented, but it is top figure shows tide gauge data sets, about 40 years observations available from permanent surveys for mean sea level. This is something like we need separate noise from trend and define acceleration. We need quite long time series. And you could see that African coast, Southeast Asia and South Asia, empty spaces. We don't have observations. Of course, there is improvement. And this ESA-funded project, which in progress now, you could see that we have many more dots along the coast. But it's still scale on the right shows kilometers from the coastline. And we know, you saw presentation from Iman, you need observations very close to the coast. I have to give credits, of course, to her. She had beautiful presentation, but it's a lot of work. It's not possible to do on a large scale. It's just individual projects. The main reason why I show all this, I really hope that there would be consideration somehow, in addition to this ESA project, have data portals when a developing country could actually get access to the data. We saw a lot of very nice platforms today, but I think it's mostly about European Copernicus Center and what is possible. But I think it is just to give some ideas that we need maybe a little bit more in other places. I don't think we don't have time for, yeah? Okay, so just to summarize, in 20th century we had only 20 centimeters sea level rise, and even if we stop emission now, we already will have more than ½ meter. But if we do not stop, it will be 1–2 meters by 2100. And you saw in many presentations about acceleration. We know it is about contribution from ice sheet and warming of the ocean. And of course, that the sea level rise is, I didn't have time to explain the mechanism, but it is crucial to increase frequency of extreme, even if you don't have cyclone. It's artificially just change probability. And the most important that, of course, coastal communities, it doesn't matter if it's large mega city or is it small village, they rely on our results to make decision about adaptation. And of course, we try to our best, but I think our models will improve if we have more observation along the coast. And I really would like to support Iman's presentation and Anya that the coastal part is very complex and a lot of resources to interpret the data. Yeah, and I think my last point is we need sustainable observation. I know we're all excited about SWOT and we're all excited about other missions. But from practical point of view, to make a decision about adaptation, we need a long-term time series. An important part, we know about the global, but in regional, we need to know where acceleration starts in individual location. If we do not know that and miss that point, we might not have enough time to make decision about coastal defense. Of course, now we don't need 30 years, like example about London, but in general, I think monitoring of sea level rise close to the coast will be game changer, like it used to be with 1992 when we look at the picture of changes. Thanks a lot.
Thank you, Svetlana. Thank you very much for this recommendation that perfectly ends this session. We covered a lot of subjects today, this morning, from science to application, monitoring the ocean, understanding the ocean, attenuate the effect of the impact of the human activities, adaptation, and for each steps of this kind of transition, I hope we have convinced you that satellite is essential for all these steps. So thank you very much for the audience to have stayed in the room. Thank you to the audience online. There was more than 400 people connected this morning. And lastly, thank you very much to all the speakers, all the experts that came, especially for this monitoring of the ocean session. Thank you very much and have a good day.